Now for vectors v1 equals 0, 0, 0, v2 equals 0, 0, 0, and v3 equals 0, 0, 36, the equation c1 v1 plus c2 v2 plus c2 v3 equals 0. Does the equation have solutions? Okay. Does it have non-trivial solutions? Are these vectors linearly independent? So, we can write this equation as this matrix equation, and the matrix equation, or the augmented, we could write it as the augmented matrix. We could write it as a matrix equation. If we did that like we did down here, the matrix would have columns of zeros. It would be non-invertible, clearly a zero determinant. And that would indicate that you're going to be able to find C1, C2, and C3 that give you the 0, 0, 0. And not all the C's equal to 0. Okay, well anyhow, the matrix reduces to this. So this system is equivalent to this system, and this system says that C3 equals 0. That's all it says. It says nothing about C1 and C2, does it? That means that this system would be solvable for any, that any C1 and C2 would constitute solution to the system, okay? So it's true for any C1 and C2, and I should have said if C3 equals 0, because if C3 doesn't equal 0, it's not true. Okay, because obviously this equation says C3 equals 0. So is that the case? Well, does it matter what C1 is? We multiply C1 times V1, well V1 is a column of zeros, so whatever C1 is, C1 times a column of zeros is going to be a column of zeros. And C2 times V2 will be a column of zeros for the same reason. So as long as C3 is 0, it doesn't matter what C1 and C2 are, you're going to get the 0 vector when you add these up. Again, C3 has to be 0 because the V3 vector is not a 0 vector. Okay, now there was a question that might seem a little weird. If the matrix and I didn't specify what the matrix is, but the matrix would be just this matrix, okay? And we see that this matrix reduces to 0, 0, 0, 1. Well, this matrix could also clearly reduce to this, which I think is a form that's specified on the problem. That might be a little confusing, but it still says exactly the same thing it did when I had the 1 here and the 0 here. It still says that C3 is 0, doesn't it? So negative 3 times C3 would be 0, so C3 has to be 0. And it says nothing about C1 and C2, so everything is still true if the matrix reduces to this. Okay? So that looks a little strange. It looks a little strange to me, but it can still be interpreted. Okay. So anything else I want to say about that? I don't think so. On number 5, it says an augmented matrix reduces to this. It misleadingly mentions x1, x2, and x3, but if this is an augmented matrix for a system of equations, then you have only x1 and x2 because, of course, your last column is what's to the right of the equal sign. In that case, this solution tells you in the second line that 0 equals -1, which indicates that there is no solution to whatever system reduced to this. Okay, no solution. It doesn't say anything about C1 and C2 except that it's not possible to have a solution to all three equations. Now, if the augmented matrix reduced to this, that would mean you had 3 equations in 2 unknowns. So this is like 3 equations, 2 unknowns. And that will often give you inconsistent equations. The first 2 equations will typically give you a solution, and that solution will typically not fit the third equation unless for some reason the equations are consistent, okay? So that's the case here. These equations would have been inconsistent.